Hello, class. I did not have much time today to record all the remaining videos, actually three of them, but I really want to record at least one uh, this evening. So here I am. I need to make a correction on something that I recorded yesterday on problem 72. I work all your problem and I found the answer of actually 6.05. Okay, however, right here, 6.05 is equivalent of the 70% of the time. Okay, in this case, it's asking me it takes more than how many minutes than the 70%. Therefore, I'm only calculating the remaining of my graph, just the little, not the little, but the other 30%. So in this case, I would have to actually do the other way around, which if you would go to your table yesterday, if I'm not mistaken, let me quickly do this. My Z, so I have a mean of 5, a standard deviation of 2, and I'm saying that 70% of the time, if I go to my table, but really I have to look for 30%, but right here, what I did yesterday, I looked for 70%, and I found about, okay, now I did an average of this two, so I found an actually a z-score of 525, and when I did this formula right here, I did x. I'm actually calculating for x. So x minus um, the mean 5 divided by 2 equals to the 0.525. Yesterday I was showing the other way around and I heard it could be confusing. So I'm just putting the value on this side now, the z value now, I'm putting on this side. Either way works. You multiply both sides by 2, you're going to find x minus 5. And then if you multiply the 5 by the 525, you're going to find 1.05. Okay, and then you're going to do x equals, um, then you put the 5 on the other side now. Oops. I can do a space here, plus the 5, and that's how I found this 605. However, I found this 70% of the time. I only want to find it 30% of the time. So in that case, I would find 30, which is exactly the remaining. So if you look for minus 0.525 would be about, so there's my 0.5, and then I look for the 2. That's about 30%. If I average this two, I'm gonna get minus 0.525. Okay, again, minus zero point 0.5, and then I'm averaging the 0.02 and 0.03 to get 25. So right here, okay, so when I average this two, I'm gonna get about 30%, which is exactly what I want, because I'm looking for more than. So if you would just change here to minus, now you're gonna have a minus 1.5, correct? Because you're gonna multiply both sides by 2. So x minus 5, and then the 2 times minus 0.525 is minus 1.05, and then x, now it's gonna be actually minus 105 plus 5, which is 3.95, which is C and not D. Okay, if I would ask you 70% or less, that would be 6.05. Since it's the question is asking for more than 70%, so I am eliminating all this and I'm just calculating this portion right here, more than 70%, this portion right here. which would be 3.95 minutes. That was the correction for the problem that I posted yesterday. I truly apologize for that. And now let's try to do this problem. I might go quickly, and since it's a video, at least you can stop and go back, and hopefully that will help you. I did put our graph here one more time to show you the percentages. I already added here that an IQ is normally distributed with a mean of 100. There's my mean, and a standard deviation of 15. So all I did, I just multiply accordingly. So one standard deviation plus 15, two standard deviations, 2 times 15, three standard deviations, so far so on. And the same thing below the mean, which I'm subtracting 100 minus 15, and then 100 minus 2 times 15, 100 minus 3 times 15, and 100 minus 4 times, because we don't really need the 4 standard deviations. But again, I want to give you very precise numbers. On your midterm, you can only use the 3 standard deviations, which is that all you're gonna need usually to answer the problems. Okay, so let's start here. Letter A is just asking you to write the equation. How would you write that? So if you remember, for a normal distribution, you're gonna have x and then normal, where in my mean is gonna be on the left side, and my standard deviation. And then you're asking yourself, where did she get that? My mean 100, and right here my standard deviation 15. This is what it means. It's telling me it's a normal distribution with a mean of 100 and a standard deviation of 15. Let's now solve problem number, uh, actually letter B. Is asking me for the probability that a person has an IQ greater than 120. Oh, okay, and then equals. Okay, so very careful. Is asking you for the area about, let's say 130. Okay, about there. Greater than. I just need this portion here. Everything else, it's smaller than what I want. So be very careful. You are gonna get a small value over here. Okay, you should get a small percentage, since I want it greater than 120. How you do that? You're gonna do equals. Well, we have x, we have the mean, and we have the standard deviation. So let's do x, it's 120 minus my mean. I'm just doing this formula right here. Okay, and we're gonna divide that by 15. Okay, and there we go. My z-score, I'm not done yet. So my z is equals to 1.33 if you round it. Okay, so now what are we gonna do? We're gonna go here to our table, and then we're gonna look for a value of positive 1.33. So we're gonna do z 1.3, and now we're gonna look for the column 0.03, because we're combining these two, we're not adding, which you're gonna find a 0.9082. 0.9082. So my z at 133 is 0.9082. And then you would tell me, okay, I'm done. No, you're not done. You just found that all these values up to 120 is 90%. It's actually 90.82%. I'm asking you for greater than that, which was my mistake over here. So greater than that, we're gonna have to do my whole table 1, because 100% minus this value. and there you go. That would be your result. You would so the probability that the person has an IQ greater than 120, which you would expect to be a small amount, is actually 9.18%. Okay, or if you don't put the percentage, then it would be 0.0918. Remember, if the 9 is right next to the period, that's 90%. For part C, is asking you Mensa an organization whose members have the top 2% of IQs, of all IQs, before everything else is 98%, and then find the minimum IQ needed to qualify for the Mensa organization, and then write the probability statement. The way we're going to do this is if we know that 2% of all IQs are on the top portion, so we know it's just this right here. So we're going to find the minimum value that is needed to qualify for the Mensa organization. Okay, so the way we do it that since we know 2% is the top, we know everything else is 98%. So let's go ahead and find on your Z table, okay, the value close to 98%. Okay, because see here are showing the values, everything under the value that you're trying to define. So we're gonna look at 98%. So let's see about right here, which is 2.0. And then let me go up to see the header. 2.0 and then about 98%, 2.06. 2.06 would be for everybody else, the 98%. So we can just get the little portion, how much or where's the IQ that is needed to qualify for Mensa. So we're gonna do, so we just said that our Z is 2.06. Remember, 2.0, and then we don't add combine 6 because this is about 98%. Even if we average this out and we put 2.055, anything that ends with a 5, we round it up. So let's just do 2.06. And then now we're going to solve for x because it's telling you right here, let x be equals to the IQ. And it's asking you find the minimum IQ. So you're really finding x. Now that you have your z, your mean, and your standard deviation, you can do 2.06 equals to x minus 100 divided by 15, right? Oops, that's not my equals minus. Therefore, we have, if you multiply both sides by 15, you're going to have equals to 2.06 times 15. That's what I thought. And then x minus 100. Wait. Okay, and now you're gonna do 30.9 and you're gonna move 100 over here plus, or should we do equals 30.9 plus 100, which is equals x, and that would be the value, the minimum IQ needed to qualify for the Mensa organization is 130.9, which is right about here. Okay, and remember your z-score was 2.06. So it is correct. And then the last one for tonight, we're at, it's the problem is asking for the middle 50% of IQs. What the middle 50% of IQs fall between what two values? Talk about interquartiles. I can barely say that word. Range. We know that your Q1 wait, is equals 25. Your Q2 is equals 50, and then your Q3 75. So that's your range. and it's saying the middle 50% of IQs fall between what two values? Well, I'm telling you right here that it falls between the 50% falls between the 75 and the 25. So in order to, oh, I forgot to put the probability statement here, didn't I? So let's say the values are gonna be between 0 and actually for Z, because we only have the Z value, it's gonna be 2.06. That would be my probability statement right here, which is equals to, and then there's your value right there. Um, we can move this, actually put it right here, and then make it this a little bigger. There we go. So that's your probability statement. Since we had the z-score and then we found the x value based on that z-score. So back, sorry, to letter D. So we're looking for these two values right here. So we need to refer to the z-table. Quick thing I'm gonna mention, and I really don't want to confuse you all, but someone also asked me, is there a formula in Excel that could calculate all this for me? Yes, there is a formula in Excel, but you would have to know when you're using your normal distribution, which tells you, as long as you have the x, the mean, the standard deviation, this it explained to you. If you click right here when you put a formula, it tells you, explains each one what is. So probability density function, which is the one that we use, you would put false. So you always would be using false on this part right here. But you would have to have your x value, your mean, and your standard deviation. However, if you have your z value, which is the other way around, you gotta use the formula norm INV. Well, it's asking me for the probability. Here's the part that you gotta be careful, because right here, 70% of the time you're not gonna be putting 70% right here. You wanna know it takes more than, so you really be calculating the 30%. So you need to make sure that this probability will be correct. What exactly you're trying to find? You're trying to find only the 30% when your mean it's 5 and your standard deviation is a 2, correct? So let me see if that works. Here we go. See how they are the same? So yes, we do have a formula, but if you are not very experienced with Excel, you got to be very careful when you're using the norm. Oh, and another thing is, if you're using a normal distribution function, you notice that you have norm.dist and you have norm.s.dist. Why? Remember when I said when we're working with the population, then you're gonna have your mean and your standard deviation symbols for the mu and the sigma. So right here is just for the population. If they're not telling you there is a class of 100 students and we're just going to be talking about 30 of these students, then you would be talking about a sample and you would be using this normal distribution. As for the sample, okay, the difference should be very minimum, but it does change. And the same thing for the norm invert, which is just showing you the part that the other side that you want to find from the value. So in this case for the population right here, and then S because of the sample. So if I would be talking about a sample, you would be using the one with S. And if I'm talking about just the population, I'm not giving you any other answer, any other information, such as right here, the length of time it takes to find a parking space follows a normal distribution. I'm not saying that, well, I'm just only at 3 parking space out of the whole parking lot. Here is not specifying any of that, so it would be considered as your population. Okay, so we do have the formula, and I want to show you that. And the same thing you could do for the other problems. Um, but if you're not very experienced with Excel, it can get very confusing. So right here, let's just finish this since it's been a long video already. Let's calculate the 75%, and then we're gonna calculate the 25%, and then we can get our values. So for 75%, we're gonna be looking here and would be about point 60. Well, this is above. Here I can round it up, but this is past. So let's say it's a point 67. Actually, let me do the other way around, because if I look at the 25%, which is the other side of the curve, so we have a value, and I'm looking at this side, and then the 75% is over here, okay? So if we calculate this one, then we can have the values for both. Let me show you what I'm talking about. Let's get 25%. So it should be around right uh, right about here. 25, not 2. Oh, I'm sorry there. Okay, let's go down. 25. See, I almost made that mistake. Minus zero point 0.6. 25. Okay, here I can round it up. Uh, 7. I'm above. Okay, let's just say it's about 0.665. It's gonna round it up, so might as well just do minus 0.67. So let's say for D, for my 25%, my Z is equals to minus 0.67. Okay, not uh, see how it's a 0.67, not 1.67. So it will be the same as 0.67. That's why you convert it right here. So now we're gonna be solving for x again. So let's be doing x, which is gonna be minus right here z 0.67, which is equals to x minus 100 divided by 15, and then we're gonna multiply this value by 15, multiply both sides, x minus 100, and then we're gonna have minus equals this value plus 100. So we found the lower side, the 25% of my, okay, see here my curve, you know that this portion right here, if you add those, is about 68%. And I'm talking about finding a value of 50%. So it's really this 50% of IQs will fall somewhere right here. And like we just calculated on the 25, we have a Z of minus 0.67. So it's about here. And therefore the other side, it's gonna be like a mirror, but it's gonna be on the positive side, which is gonna be 0.67 instead of a minus. And the way I can prove that, if I look for the 75%, about here, which I told you before, you're gonna see it's 0.6, and then right there, if you average those and you round it up, then let's just say 0.67. So it's gonna be right here in this portion. So let's just, instead of having calculated everything, we did the minus, so we can just add the other side. and do, so I'm gonna do right here on the bottom instead. I'm gonna do equals 10 point. I'm doing a positive side plus the 100. Okay, and then if you round those values, so your range would be between 90 and 100. Okay, would be between 90 and 100. This area right here. So the middle of IQs falls between these two values here, 90 and 100, which would be right here. And that's all for tonight. I apologize if I gave you too many details and went too long on the video. I just want you to see where all the numbers come from. It's very important to see which side of the table you're using. Okay, right here is showing me these are percentages are for all the values below this Z score right here. And this side, the negative, is showing me for all the values below this Z score here, which is just this little portion. And this would be this whole portion, just leaving this out. Okay, so I hope this helps. Thank you.